Matthew first, and today we're going over 3.6 metals from the Cambridge IGCSE Design and Technology specification. And metals are mined from ores, which ores are crushed, heated, and refined to form the market form of metal, which we get. And ferrous metals are metals that contains iron, the iron element, and non-ferrous metal does not contain iron. And an alloy, according to the specification, is a mixture of two or more metals, but more accurately, it is technically a mixture of at least one type of metallic element and another element, but it's fine. Both are technically correct. Uh, two keywords you need to know is brittleness. It means that it doesn't really flex, and when it breaks, it shatters, but it does not mean that it has a poor tensile strength. It just means that it just doesn't stretch. It may as well have a very high elastic limit, but it just doesn't stretch. Yeah. And work hardening is when the structure of a metal alters because of working, like the layers could be a bit distorted, so it just changed the structure completely. And ferrous metals conduct heat and electricity because of the delocalized electrons. It reacts with oxygen and water to rust. The equation is shown below, and it has a high melting point because the partially filled d orbitals that provides less shielding, so that would be a higher net positive charge of the nuclei to the localized electrons, so there would be a stronger electrostatic force of attraction to overcome. So we can see that ferrous metals have a higher melting point for that reason. So cast iron is the ferrous metal of the lowest melting point. It is basically just pure metal, and therefore it is quite brittle and very prone to rusting. It is usually just used in manhole covers. Stainless steel is a mixture of iron and I believe chromium. So it is used in surgical equipment and cutlery because it is quite hard and corrosion resistant, and you can really sterilize it with gamma rays without really altering it or reacting with it too much. And there's also high speed steel, which is iron plus tungsten and vanadium. It is very brittle but very resistant to wear, and therefore are used in drill bits. And we have also got mild steel, which is iron with a very low content of carbon. It is very malleable, quite tough, quite ductile, have quite good tensile strength, and is used in like bolts because they have to like stretch a bit, if that makes sense. High carbon steel, the higher carbon content makes it a bit more tough, a bit more hard, but it also makes it more brittle, and therefore it is used in materials like hammers. And for non-ferrous metals, there is first lead. It is just lead. It's used in batteries. It is quite soft. So tin is very malleable. It is resistant to corrosion by moisture only. So it is used in coating for food cans. Zinc is very malleable and soft as well, but weak on its own. But it has fantastic resistance to corrosion, and so it is used in coating for boats for outdoor use. And aluminum is aluminum plus copper. It is very strong, very hard, but also very lightweight, so it's used in aircrafts. Aluminium is quite lightweight, have very good thermal conductivity, has a very high melting point relatively. I believe is 560 degrees Celsius, so it is used in saucepans. Brass is an alloy of copper and zinc. It is corrosion resistant. Uh, it is golden yellow, so some people would use it to scalp, but it is also used in the pins for UK plugs because it is quite corrosion resistant, quite hard, doesn't really deform, um, but it is still a good electrical conductor. So bronze is copper plus tin, which are really just used in sculptures. It is casted into shape. And the last copper, it is very ductile, very malleable. It's a very good electrical conductor and is used in wires. That is because it can be take the form of 2 plus and 3 plus, which means that it has really quite a lot of electrons to contribute to the state of the localized electron, so it can conduct current quite well.